All right, let's run through 7.2 quickly. So 7.2 deals with the transformation of these exponential functions, which you explored in 7.1. I've got an exponential function here, y is equal to the base of 1/3 to the power of x. And I would like you to see, if you already know how to do this, where would you put this vertical shift of down 3, a horizontal shift of left 5, a vertical stretch of factor of 2, and a reflection about the y-axis? Pause it and see if you know where to put those transformations in that equation. I bet you already do. And then press play and I'll show you the right answer. Did you get it right? So here's your base equation with the a, b, h, and k. And we can see here that our base is called c, and we have to have c is greater than 0, of course. Our a, again, is the vertical stretch. As you already know, we have the horizontal stretch. And of course, if a or b are negative, we see the reflections. And then we have the h, of course, is the horizontal translation. You can write the words out in full in your notes. And k would be the vertical translation. Transformations of exponential functions are used to model situations such as population growth, carbon dating of items found at archaeological digs, the physics of chain reactions, etc. Let's do example 1 together. Okay, we can see that the c in this equation, or the base, is greater than 1, so we know that this function will be increasing. We can see that the base is 3, and so we're going to use that 3, or y equals 3 to the power of x, as our base graph. And then we're going to use mapping to do the translations that we can see in the equation, the a of 2 and the h of -1, or positive 1 to the right, and the k of -1, which would be a translation of 1 down. So here's the table of values that is exactly what I just said. We're going to take the x comma y mapping from the base graph of y equals 3 to the power of x. And we're going to map that, and our new x coordinate will be x plus 1, and our new y coordinate will be 2 times y subtract 1. Okay, go ahead and fill that out. We're going to use for our original x those same numbers we picked in 7.1, the -2, -1, 0, 1, and 2. Like this, and I'd like you to pause it and then figure out the new points using mapping. I believe those should be correct, and you'll also notice that on the bottom of this table of values, I'm going to also consider the shift or the translation of the asymptote. It will move with the y-coordinates 1 down because of the vertical translation, or k. All right, so go ahead and plot those points and check if your graph looks like mine. You can pause it here. There's the points, and you'll need to extend your x-axis so 3 fits on. I just put the dot there on the edge of your screen. Something like that. And so that's a good example of translations. Let's move to example 2. All right, example 2 gives us this equation. It's exponential because the x there is in the exponent. And we are supposed to consider the domain range equation of the horizontal asymptote and also the intercepts. Okay, so domain will be x, remember, of all real numbers. What about the range here? We do see, if we would consider the mapping here, let's just do that. We will have our x value. It will be stretched by a factor of a half. and we see it will be shifting to the left 1 because of the h. And our y coordinate, we see a reflection as well as a stretch. So -4 times y and +4 up. Okay, so we see our regular graph has a range of y is greater than 0. And this entire graph is then going to be reflected. So if we consider the range and the reflection will turn the domain to be y is less than 0, right? If the original was y is greater than 0 when we reflect, then y will have to be less than 0. Then we see that the y-coordinate is multiplied by 4, which will still have a y is less than 0. And then the y-coordinate is shifted up 4. And so here we have up 4. So we have our range now as y is less than 4. Y is such that y is less than 4, where y is a number of all real numbers. All right, then the horizontal asymptote. Well, if y has to be less than 4, we have an asymptote at 4. Good. And now considering the intercepts, let's think about the y. When we have a y-intercept, we know that x will be equal to 0, okay, on the y-intercept. So we're going to write that equation down. I'm going to move my screen over just a second. So I've written that in the black there. When we have a y-intercept, we know that x will be 0. So I've taken the equation and put a 0 in for x. And we can manipulate that equation now so that we have -4. Remember to use bedmass here. We'll figure out the exponent, which is 2 times 1. So it's going to be 3 to the power of 2. So we do exponents, which will be 9. Multiply that by 4 and add 4. What did I do? Oh yeah, the -4. All right, so that's -36 plus 4. We'll have a y-intercept at -32. And the x-intercept, okay, our x-intercept happens when y is 0. So you can see in the green there, I replaced the y with a 0. Now, we have to consider what's the x value that makes y equal 0. So we have a +4. Basically, if we can get the first term in that equation equal to -4, then we would add +4 and we would equal 0. So, and we do have this base of 3 to the power. That's being multiplied by -4. So essentially, if we think about this, if that underlined red spot equals 1, then our equation equals 0, or then y is equal to 0. So we know that 3 to the power of 0 is 1. So basically now, what color haven't I used? If I can make this exponent equal 0, then my entire equation will equal 0. So if I want that to equal 0, I'm going to have x as -1. If x equals -1, and try that for yourself, put a -1 into there, then the entire equation should equal 0, and that's going to be our x-intercept. Here we see a translation from the base blue graph to the red, and we are asked to write that function in that form y equals b to the power of x minus h plus k, where b in this case is the base. Okay, we see a translation now from here over and then down, this point here. And so we can see a shift to the left of 4 and a shift down of 1. Now, what was the base in this case? If we look here, we're looking, well, the base was 2. It says right there. 2. And done. One more thing here. I do want you to go to the bottom and fill this yellow box in. Because for some reason that didn't print when I printed your notes. So number 7 in the assignment presents a transformed function in this way, where f of x equals the base function, 3 to the power of x, and then it says y is equal to 1/2 times that f of x, where instead of putting in an x, you're putting in an x minus 1. And then you're subtracting 5. You can see when I rewrite that as one equation, I get, and this is on the bottom, y is equal to, the a is 1/2, 1 over 2, times the base, 3, to the power of x minus 1, subtract 5. See if you can figure that out. That's what number 7 uses as its transformed function, and you'll need to understand that. Okay, there's the assignment, and Ms. Cantillon will help you through that.